I'd like to welcome Michal Styszynski, who will be presenting seamless data center interconnect options using EVPN and various tunnel stitching. Michal is a 20-year industry veteran and currently part of the product management team at Juniper Networks' cloud-ready data center business unit. This is Michal's first time on the analog stage. Welcome.
Thank you. Thank you, Chris. So hi, everyone. Thank you for the introduction. So this session is about data center, and data center interconnect. So it's a North American operators event, but data center is important for operators. Especially, we observe that in Europe, most of the service providers we work with, they are deploying massively edge data center, regional data center, and national data centers, right, to deliver 5G as a coherent solution with the right bandwidth, with the right secure access to the data closer to the user. So that session is all about this. Obviously, we've seen also during the pandemic time that getting this fast and reliable, secure access to data was important as well. So making sure that the statistics you are getting on time, you got that from the reliable source, was critical, right? So pandemic is over, but still there are a lot of lessons learned also. So this session is actually about how to deliver data center interconnect, replications of the data in different regions of the country in a simplified way. So deploying data center interconnect, it's not necessarily something new. We used to have VPLS for many years. Many telcos are still using VPLS as an approach. Next gen moving to the EVPN, MPLS as a service. But in this session, we'll see both angles, the data center EVPN-VXLAN inside the fabric, as well as the DCI, simplified way of deploying the DCI other than just using MPLS as a transport. So here is the agenda of this session. So we'll explain actually why seamless data center interconnect makes sense and how you can actually integrate that solution in your tooling in order to simplify the way you actually deliver the data center interconnect service. Then we will go through different data center seamless connection options with different encapsulation formats. Some examples of the packet walk involved in the seamless DCI, and we'll finish on summarizing what's good, what's bad about all these solutions. So why seamless data center interconnect? We mentioned about different services like 5G, storage replications, symmetric storage replications between the regions, metro replications in the larger cities. That's another use case. So deploying these things only using MPLS as a technology, sometimes it's not so easy or has a specific cost, right, associated. So that's why in the industry, we came up with some of the simplified solutions to deploy faster the DCI solution. So for any stitching functions that we will see later on, they are especially making sense when you deploy EVPN-VXLAN inside the fabric. So it means that you have your leaf spine, super spine, or leaf spine leaf, three-stage IP closed fabric in the LAN, and then you actually have to deliver the interconnectivity with one site or multiple sites, right? So obviously, in the enterprise context, quite often it's like 2-3 sites. I visited last week one of the Swedish federal customer. They are just having like 2 main data centers and deploying smaller regional ones. So on the other hand, in a country like America, you typically deploy much more data center sites for the same service to replicate the data, making sure that the user gets it quicker. So seamless stitching helps whenever you deploy your data center with EVPN-VXLAN, then it can actually help you to scale out. Means I deploy 2 sites, but then maybe my service is growing, and then I need to connect more of these regional or smaller edge data centers. And in order to scale out, I need to have a form of control over how many of these tunnels I'm going to create when already in my fabric, I have a pretty decent number of overlays. So with the new stitching solutions, which are now ratified at the IETF level in RFC 1914, we have actually a tooling which helps us to control that scaling at the edge of the fabric, at the DC gateway level, or at the border level. So we'll go through different topologies, architectures, where, in fact, that RFC 1914 is applicable. And that gives you as an outcome easier architecture extensions. Whenever we need to connect another pod in the DC, we would connect that new pod to just a pair of border devices instead of enabling a mass mesh of VXLAN tunnels with all individual devices of the same data center fabric. We'll see that on the diagrams. It's going to be much easier to actually understand. Second point, whenever we build LAN Ethernet data centers using EVPN-VXLAN, we still have a bit of flooding, right? It's not that Ethernet is, part of the Ethernet is flooding as well. So in order to reduce that flooding between the data center sites, we have a tooling which actually helps us to either identify which workloads needs to be extended, and it means that at the border of the data center, I can precisely implement my flood firewall filters to control the rate of the flooding between the data center sites, right? Instead of having like a full overlay, which actually goes directly to the leaf where the server is connected and just would simply flood that server immediately, right? Additional virtualization options, that's another motivation. So when we have different DCs, we can actually have some acquisitions. So there are examples of service providers, they are just buying a data center provider, and they already have some EVPN-VXLAN deployments. In that situation, we can use the virtualization options of remapping the VNIs from one site to a common data center interconnect VNI with that RFC 1914. Improved operations, it means that extending the L2 domain from one site to another is just much more simplified. We don't have to call the core IP guys. When we are managing the LAN data center, we can do it ourselves. So it's just a simplified way of delivering end-to-end connectivity. What are the two main use cases? So we talked about the DCI so far. And so it means that we can have large or medium DCs and then different formats of NCAPs. You can see here on the slide that we have the VXLAN to VXLAN as one of the stitching options. Then another one is the VXLAN to MPLS and the VXLAN to SRv6. Not yet so much popular, but I think this one is going to be, let's say, popular in a couple of years whenever the telco deploys SRv6 for the 5G core. And then the second use case is the multi-pod, right? So you can have DC Fabric 1, DC Fabric 2, and then it's delivered as a pod 1, pod 2. Then in order to interconnect these two pods, we'll use the same technology from the RFC 1914 to actually stitch the tunnels for the LAN, from the LAN purposes to get the interconnect tunnels between the pods. And then last one as an example of service is the server overlay connectivity. So we know that VMware is also betting on EVPN. They have the Type-5 routes supported in their solution. So whenever we want to concentrate the connectivity of VMware with the IP fabric we have in the data center, then we can stitch the Type-5 tunnels from the VMware to the fabric itself. These are the main two, let's say, DCI plus multi-pod. From the architecture point of view, these are the two main use cases. So I talked about the simplifications, how to simplify the DCI connect. So whenever we have the fabric deployment, you can see here, we have one site with leaves, spine, and border. So let's say this is site A, this is site B, and in the middle, we can either have a dark fibers connect or just another level of super spines. And we can simply, in this option 1, use the L2 handoff, simple flood and learn connectivity with clear demarcation points. That's one of the options. I just split my domains from the interconnect to the fabric using a simple L2 handoff, right? Very popular whenever you have just two sites to interconnect, not a big deal. I can then use either another domain of EVPN-VXLAN in the middle, or just deliver the EVPN MPLS as a DCI technology. Then the second option is where we have an OTT over-the-top solution. We have, let's say, 2 data centers to connect, small number of leaf devices in site A and site B, and then the leaf devices will just get connected directly via the tunnel. Once they signalize all the route types using the BGP, then they get connected together across the intermediate IP domain directly. So for very small deployments, this is the easiest way of getting L2 and L3 connectivity between the data center sites. That's why this is really popular as a solution. And then the focus of this session is really the option 3, right? Because the option 3 is like stitching these LAN tunnels you have in site A to the interconnectivity using still BGP as the signalization protocol. So we are not changing anything from the EVPN BGP control plane point of view. We are just rewriting some of the control plane messages to terminate the LAN DC and originate new tunneling from the border, right? So we have that notion of border spine, border leaf. We'll see that on the diagrams. And then we still stay consistent with the control plane messages, same EVI, EVPN instance. For people that deployed EVPN, they know what I'm talking about. But this one is really offering a more coherent solution, so we can leverage things like MAC mobility, for example, from one site to another. In case of option 1, whenever we actually break the domain using just an L2 handoff, then all the beauty of EVPN from that point to this point at the edge of the fabric is just disappearing, right? Because it's just a flood and learn mechanism. In case of this option 3, on which we will focus more today, we can actually scale out to higher number of sites. We can limit and unify that scaling at the specific border level. And then we have 3 other options. I don't want to confuse you more with there could be more options, but I highlighted 6 of these options. So there's option 4, where actually you stitch not to the VXLAN, but to MPLS. So you preserve the same EVPN instance called EVI, EVPN instance, and then we stitch from VXLAN as a transport to MPLS at this level. So that helps whenever you already deployed MPLS in your network to actually connect quicker your regional data centers. And then we have option 5. Whenever you don't care about L2, you may have that situation that people saying, I'm good enough with IP only, right? So in this case, you are actually deploying your IP VPN type of approach using just VXLAN as a transport. So it means I can have my IP VPN-like service delivery closer to the server, and then terminate my Type-5 instance tunnels at the border leaf level, similar to what we've seen for the L2 part, and then stitch these Type-5 tunnels to the Type-5 interconnect tunnels at the border to reach the remote site. And then last option, option 6, where we have a very, very simple scenario. We have the prefix advertisement from the leaf devices to the borders, and then the border leaf is handling all the advertisement to the IP VPN MPLS whenever the border leaf is directly connected to the MPLS cloud. So 6 options. We'll focus on 2 of these options in the next slides. We'll first start with the Type 2 to Type 2 stitching EVPN, and then for Type 5 to Type 5. Type 2 to Type 2 for MAC advertisement for any L2 extensions, and then for Type 5, it's for the IP prefixes. Again, If you need to deploy both services, you can do that. If you are good enough with IP, it means the option you would typically consider is the Type 5 to Type 5 stitching, focusing only on the IP prefixes advertisements. So this is the example diagram of the topology. Just two sites. We have Fabric A on the, for example, in one data center location. We have Fabric B in another location, either in the same country or in two different countries. And then we have in the middle an IP core, which actually is delivering just IP connectivity from Fabric A to Fabric B. And the overlays are crossing that core IP domain. So in case of the stitching solution, we actually terminate the EVPN-VXLAN domain at the border spine level, right? And we originate what we call the interconnect VXLAN tunnels. So it means, in case of the border spine solution, I can unify my scaling between the two data center sites. So if I deploy the smaller site in Fabric B and a larger site in Fabric A, my border spine block will unify that scaling. It means I can actually unify that number of tunnels terminated on each of the sites and just use same number of data center interconnect tunnels between the border spines. So it means instead of letting this guy sitting here to create an overlay tunnel directly to my leaf 12 like this, which would be the case of the OTT solution, I will always point to my local border devices as next hops, right? So again, leaf device, instead of creating a direct tunnel like this with all the other guys from the remote location, the leaf device will point to two of the border devices as next hops to reach all the MAC addresses or IP prefixes from the remote site. So for people who deployed already fabrics using EVPN technology, obviously there are all the different signalizations involved in the creation of the tunnels, right? First, you need to signalize everything using BGP. So we have on this diagram an example of 32 bits ASN numbers allocated for all the leaf devices sitting in each of the data center site. And then we have the eBGP creation establishment between the spine devices and leaf devices. And that same goes for the DCI. We have the eBGP peering with the core IP devices in order just to have a first underlay reachability and then the overlay EVPN signalization done. So what happens when I need to stitch these tunnels? The condition is that my MAC-1 address will be advertised to the remote location, but I will rewrite the original ESI value from the EVPN type 2 route. I will rewrite my route target, and I will obviously use also a different route distinguisher in order to actually terminate my LAN VXLAN on the border and then originate a completely new VXLAN tunnel to the remote location. So as you can see, all my auto discovery routes, MAC-IP, the type 3 routes, they will have the new actually capabilities in terms of control plane, and that's how we connect to the remote location. Based on that EVPN control plane signalization, we originate new data center interconnect tunnels. The good thing is that many things is happening actually underneath. So it means there is that built-in BGP automation, which helps us to deliver that kind of solution. And we can be very specific in terms of which kind of VLANs are extended from Fabric A to Fabric B. We'll define that as an operator. We can define that at the border spine level. So that's for the L2 extensions. I need to talk to MAC-2 from Fabric A. I need to talk to MAC-2 in Fabric B. I can define either I want to do that or not. If I want, I'm defining that at my specific block in my architecture. So that's really good because we want to know what's going on in our fabrics, right? From security point of view, it's really important. And then next scenario, instead of using spine devices as borders, We have in this situation a new block called border leaf block. And in this case, it's very similar to what we've seen so far. We still stitch the LAN tunnels, you can see in the blue, to the data center interconnect tunnels for the DCI purposes, okay? And then similarly, we have what is called the interconnect TSI, and that value of 10 bytes is a standardized value and actually represents the site identifier, right? It means you as the operator, we as operators, we can identify, precisely speaking, from which actually location that given MAC address is coming from. So that interconnect TSI2, we can see on the left-hand side, will actually be used as a tooling to identify whether this MAC comes from site A or site B or site C or site D, right? We can have more than 2 sites. So pretty good as a tooling to really know and understand what's the origin of that given workload. So in this example, we can see that this is just the creation of the tunnels from one VXLAN to another VXLAN. And if you read that RFC 1914, then you will understand that there are other encap formats you can use. The one I mentioned at the beginning, where actually I stitch from VXLAN to MPLS. It means in the middle I have my MPLS cloud. And obviously in this case, we have other parameters to actually fulfill. From the control plane point of view, we will be using, for example, MPLS label aliasing, which is not, for example, the case of VXLAN. There's no labels in VXLAN, right? So I think in this room we have the best representation of MPLS specialists. So in this case, we would allocate at the border leaf an MPLS label in order to load balance the traffic to these two guys sitting in fabric B at the border leaf level. I will use the technology called the MPLS label aliasing. In case of VXLAN, it's all based on overlay IP CMP. I will use my destination interconnect ESI, which I allocate for the given data center site. And I will do the active-active forwarding to these two guys sitting in the fabric B in order to reach the MAC address sitting in fabric B connected to the leaf device. So I talked about the scenario where you may not need a L2 extension. You may have that situation, right? You are deploying a new network. My L2, I just need my L2 in the fabric. Between the fabrics, I'm happy doing just prefix advertisement. Everything is IP-based. But I still want to deliver some level of virtualization. So I'm deploying my IP VRFs as a way to virtualize my network. So in this case, we can use the Type-5 IP VRF to IP VRF model and get also the similar connectivity between the sites by terminating Type-5 tunnels at the border leaf and then originating a new set of Type-5 tunnels to the remote location. So obviously there are some changes in terms of control plane. In case of Type-5 EVPN, we are not using the concept of ESI when we use the pure Type-5 IP VRF to IP VRF interface-less model. In this case, we will load balance using just overlay IP CMP. However, for the site identification, in this case, there is a new BGP attribute. So we have in this room probably the best concentration of BGP experts as well. So there is a new BGP attribute I will also talk about for that particular use case, where we identify the given site with not only the ESI for L2 purposes, but with the new BGP attribute called domain path, DPath. I'll show you that later on. So speaking about seamless tunnel stitching, we can have more complex designs in this case, where actually for some of the federal deployments, we need to make sure that some data stays in the given location. It's like per contract that you don't move data, or you're allowed to move the data from one location to very specific remote location as per contract. If it's not respected, you are breaking the law in the country, right? So in this case, we can use the technology of tunnel stitching and MAC-VRF level isolation to make sure that the data gets replicated to the right data center location. So in this case, you can see that the stitching technology is delivered at the common border block for 2 different pods, and only the MAC-VRF AC goes down to the data center site C, and then only MAC-VRF AB stitching goes to the data center site B. So it means with that technology, you get an opportunity to really control where your data is saved or replicated, right? Very important, right? This is not just the imagination of the vendors. This is per requirements of the legal, let's say, requirements. So MAC-VRF is nothing more than the definition of EVPN instance. So you know that we have, in the case of EVPN, different type of acronyms that sometimes means the same thing. It's nothing more than EVPN instance, the MAC-VRF, right? Okay, so a few words about the implementation part. So in case of implementation, we add, In case of implementation, we have a new dedicated block where we define, in fact, how this extension will really look like. So we can simply bring the definition of the site with that interconnect ESI. That's going to be our site identifier. So some more significant numbers can be used, for example, just to say this is site 1, the other one is site B. So because it's a 10-byte value, so we can define a lot of these sites. And then whenever we have to be very prescriptive in terms of the definition of the VNIs, we will define which workloads really are extended to the remote location. So the new route targets, same thing. We actually define, besides the LAN-specific route targets, we will define the data center interconnect route targets to have a common understanding between different locations. And then another example, whenever we don't want to do L2, we just want to actually manage IP prefix reachability. In this case, we have that new dedicated block as an example of how to introduce the interconnectivity for IP purposes only for data center interconnect. So if we remember the diagrams we've seen so far, right? This one, where actually prefixes are originated here, they go then up to the border, and that's at the border reef level where I will define that block, right? At the edge of the fabric. So from the verification point of view, I mentioned that we can use the site identifier as a way to trace the origin of the MAC addresses. So in this case, we have, for example, all the MAC addresses I learned here, they are coming from specific site. And in Junos, I can precisely actually specify either I'm searching for MAC addresses from remote locations, or all I'm care about is, well, the definition of the MAC addresses that are local to the fabric. And then from tunnel perspective, we have specific flags which will tell us either I have my reachability for the one connectivity, the DCI connectivity, or to the fabric, right? So we can see that that's another flag that we added in order to distinguish between different type of VXLAN tunnels, right? So in this room, is anybody deploying EVPN or did? Okay, I see some hands. Good. So so that's something we actually do because obviously there are some devices which can have 1,000 tunnels, VXLAN tunnels on the box. But it's not just about scaling. Scaling is one of the part of the story, but it's also that operational aspect, right? I am the admin of the fabric. even if I can support 1,000 tunnels on the box, managing 1,000 tunnels, knowing where they go, is pretty tough. When it's 1,000, 2,000 tunnels, even if I can scale on the box, if I check my logical interfaces associated with the VTEPs, having 2,000 of those on the box is pretty big, right? Whenever you deployed it on multiple sites. So just to sum up the two differences between a couple of differences between the stitching options for L2 versus L3, MAC versus IP. So we have stitching of type 5. We don't create any logical interfaces. It means everything is based on the rewrite of the next hops, right? I don't have to actually care about how many of my logical interfaces I created at my border. Leaf devices, everything is handled at the next hop level. ESI concept specific to the L2 connectivity. It means I will do my load balancing to my destination ESI in case of L2, not the case of type 5 EVPN. Configs, we've seen that for L2 purposes, I will handle my configuration inside my MAC-VRF, inside my EVI. And whenever I'm deploying just prefix advertisement, in this case, I will just use my IP VRFs in terms of implementation. And the last point we already talked about, that load balancing is, in case of type 5 instances, done using IP ECMP. So I already mentioned that for all the data center interconnect solutions, we have a new attribute which is emerging in the industry, and it's called the DPAF. D stands for domain path, and actually is something that probably in the coming couple of years we will identify other use cases for that attribute, but mainly was defined for the data center interconnect purposes. So just as a problem statement, so we have this topology, again, very similar topology we've seen so far. So whenever there are prefixes advertisement from one site to the remote site, we may have a situation where, because everything is based on eBGP, that the remote location will rewrite the AS path, right? The AS path will be rewritten at the edge, and we will get the same prefix we advertise to the remote location. We will actually get it back from the remote location and accept it. So the border will become quite confused on either go through the remote data center to get back to prefix 1, or as an admin, you understand every single prefix you have to manage, and you apply a lot of route maps, a lot of policy statements to manage your routing loop situation, right? So in order to simplify the way actually you control the origin of the IP prefixes or EVPN long prefixes, the industry or the community came up with the new BGP attribute, which by default will block the prefixes with the domain path, domain ID in the list of domain IDs. If we see our own domain ID, we'll drop that control plane advertisement. So we have a loop prevention mechanism by default integrated into the solution. So if we come back to that diagram, it's a little bit bigger. So we have two domains, domain 1, domain 3, and it means whenever I get back a prefix from site B with my local domain 1 in the list, I will just drop that control plane, right? And always prefer my local one from the reachability point of view. And of course, if we want to use that domain path as a way to identify sites, it's also another mechanism to do that, right? So it's pretty cool as a solution. It's applicable for IP prefix advertisement as well as for EVPN MAC advertisement, right? So we get a specific BGP attribute. It was mentioned that it's learning is part of the objectives of NANOG. So for people who didn't know, there is a new BGP attribute now you can talk about. Okay, summary notes, right? So seamless tunnel stitching summary notes means we have a solution which gives us an opportunity to create DCI services, break the domains, the overlays domains in multiple places in order to scale out. We reduce the load control plane because we simply, instead of accepting all the remote location EVPN routes, we are just actually considering the DCI for any remote location. So we reduce the RIB size and the FIB size thanks to that solution. Improve the DC and DCI control, overlay domain creation. We've seen the DPAF as a way to do that. Simplify day-to-day operations. We can have the pre-established EVPN tunneling between the site, and then whenever I need to connect a new leaf in the fabric, it's going to be hooked up to the spines only, instead of getting a new leaf device and originate an avalanche of VXLAN tunnels. It will just connect to my local border devices and be already directly connected to the remote location. Normalized scale, again, if you remember the diagram, we could use border devices as a block where we normalize the scaling between the sites. And then additional point, quite interesting, that whenever we terminate these tunnels on the border, we can add more security into the fabric, right? So I said that storing the data in the, or delivering data storage is very important, also from the reliability and the security point of view, to make sure that we get the data from the right origin. And so whenever we deploy the stitching, we can actually get additional L4, L7 inspections on the interconnectivity VNI. Instead of just running an overlay directly to the remote location, I can terminate my VXLAN on the border and then put it directly into the L4-7 inspections, right? Very important. Same goes for the group-based policy. So people who deployed in the room already EVPN-VXLAN, you know that there is that additional field in the VXLAN which can deliver, which can get you the opportunity to deliver micro-segmentation. So in this case, with the DCI, we can also leverage the group-based policy IDs between the data center site and respect the segmentation level from the one fabric to another fabric. So one of the emerging part in case of the group-based policy in the DCI context is to actually advertise the group-based policy ID as an additional BGP community. So don't be surprised if you see that in some of the IETF applications. And then flood rate control, that's another aspect. I terminate my VXLANs on the border, and I can implement my flood rate control at the border before allowing any traffic from remote location. Let's say I have an attack, right? A DDoS attack coming from the WAN. I can block it before it goes directly to the server. So I can put in place my DDoS policies at the edge of the fabric to protect my servers with that solution as well. And that's all I have for today. 5 minutes for any questions. I know that some of you deployed EVPN, so even if it's not DCI related, I'll be more than happy to get some questions from you guys. We have still 5 minutes. Any questions? Maybe from Juniper. No. Maybe from Juniper. Yeah.
From the chat. So from Blake Willis, BGP MPLS VPN, they offer some anti-spoofing knobs that you're aware of. Unauthorized traffic ingestion into the VPN. Are you aware of VXLAN implementations that offer similar protections?
No, on VXLAN we don't have that today. So that's a good question. Thanks for it. So on VXLAN, the only thing we can do is to to actually inspect the tunnel in transit on the firewall. So it means you have your routing VNI that goes across the firewall, and then all of this is inspected at the firewall level for advanced policing. That's what we have. Any other questions from people in the room? Please go ahead.
Hey. Thanks for the talk. Vinod from Keysight. Any thoughts on what's the best overlay interconnect for best bandwidth or latency considerations or outage? For example, we have had multiple data centers which have been locked by outages. So any considerations that service providers need to take or cloud providers need to take, which overlay technology to choose when system is doing well, or when detecting outages and bringing sites back up?
Thanks for the question. So for the outages detections, there are standards for OAM, also for VXLAN, and another one to detect quicker the bidirectional state of the tunnels, of the overlays, is to actually get a BFD inside the VXLAN tunnel. That's another much more simplified than OAM. So there is actually a fully standardized RFC on this, that you're running your BFD inside the VXLAN tunnel to get a bidirectional communication check. That would be one of the solutions.
Great. Second question came in. Can you anycast a gateway across borders? Not within, but cross borders.
I didn't get the final part.
Can you anycast
Anycast, okay.
a gateway across borders? Within a border, no problem, right? But across borders.
Okay, across the sites?
Yes.
Yeah. So for Anycast, obviously, if you remember the diagrams I was showing, so we have that distributed Anycast IP gateway on the leaf devices. In case of the DCI solutions, obviously, in this case, we advertise the MAC IP actually to the remote locations, right? So the local proxy ARP state is maintained in all of these solutions, right? So that doesn't change from what you have in the fabric. Still, you will continue to advertise your MAC IP to the remote location if you extend the L2 context to the remote location. Otherwise, if you don't extend, it stays within the fabric only. Was that the question? Yeah. No, in this case, you can either stay with your EVPN-VXLAN L2 in the fabric, or if you extend it, you still preserve the same approach of getting Anycast gateways in one location and the other location, right? So same Anycast gateway would be replicated in the remote location. So it means, in consequence, it means you still have to do all the control plane rewrites at the edge of the fabric, right, for the MAC IP. Yeah. Any other questions? No questions? Okay. So I hope you enjoyed the session. Please, I will be around roaming in this location, and we can get either coffee or beer in French, English, or Polish, which language you prefer. So I'll be more than happy to hang out with you guys. Thanks again. Okay.